This is Cosmographia, the Randall Carlson podcast.
Welcome back, ladies and gentlemen, to Cosmographia, the Randall Carlson podcast, where we are all still sheltering at home.
Quarantine.
So, how are you guys doing out there? Brad, how you doing, buddy?
I'm lost in space, brother.
And, of course, Silent Mike. No comment. Oh. And our star of the show, amidst looks like a raining asteroid or cometary bombardment, Randall Carlson. How you doing there, buddy?
Well, considering everything, I'm doing quite well.
I think those are Leonids. Are those
Is
Leonids?
that the Leonids?
Yeah, that was a photograph taken during the 2001 Leonid meteor shower, one of the great meteor showers of the year of Earth's circuit around the sun. I like this photograph because you can really see the parallelism of the debris within the stream. Of course, this is time lapse, but I'm sure it's pretty quick because these suckers are moving fast, 20, 30 miles per second.
Wow, that's beautiful. Yeah.
Yeah. So Leonids, yes.
Now, that's one that had a crazy peak in like 1966, right? And then
66, I believe, was the year. Yeah.
They were expecting another one in 99, and it wasn't so extravagant, but it's on some kind of cycle where they've realized that the pocket of material, in its orbit is going to show up on that cyclicity. Yeah.
The clump. That clump. Yeah. So you got, the idea is that the material is not uniformly distributed around the orbit, but is clustered in places and thin in other places. So if the cluster happens to be intersecting the Earth's orbit at the time the Earth is there, then we're going to get a spectacular shower. And it looked like, and I've forgotten the year now. It looked like one of the recent years was going to be spectacular, but didn't quite sync up enough. And then sometimes one hemisphere may get the full blast and the other hemisphere misses it.
Yeah, I think was it the Geminids that were really great out here? The ones
that would make sense.
Yeah,
mm-hmm.
They were really good this past December or whenever
Yeah,
that's right.
Yeah, the Geminids were really good here, so they were fantastic.
Now, Russ, why are they called the Geminids?
It's Gemini. The radiant is coming from Gemini. Is that right?
Yeah.
Okay.
Excellent. You want to explain what the radiant is?
The apparent point of origin. So like if you see in streaks across the sky, if you're able to trace those all back, they kind of point to an area and it points to the constellation of Gemini. So they call it the Geminids because it appears to come from that direction.
That's pretty much it. And that's the explanation.
What are the ones that happen that we do for my birthday? I can't remember what those are called. The August.
Perseids are in
Perseids,
probably,
right?
Yeah, the Perseids are they're. Mm-hmm.
One of my favorite things to do
go ahead, sorry.
One of my favorite things to do for a birthday party, because my birthday's in August, is we all kind of hang out real late up on the deck and watch the Perseid meteor shower. So
here's the idea right here behind the radiant.
I thought that was your shot of your birthday party.
That's it. That's the Texas Road and the radiant right there.
I went out along a desert highway all by myself and had a party. So here's the point. You got the perspective on the highway here and the high tension wires, everything converging to a point. So, but what is that in reality, this stuff is not converging. It's coming in parallel lines. So the analogy works here for the meteor radiant. It gives the the illusion of emanating from a single point, but really these things are coming in straight lines. And the radiant is the central point upon which it appears the whole system is targeted. It's the bullseye, if you will. And wherever that bullseye happens to be, whatever constellation is behind it gives its name to the meteor shower. So
Right.
obviously the Perseids would be which constellation?
Perseus.
Perseus.
Yeah, Perseus. Exactly.
Now, are these constellations all zodiacal, or can they be anywhere? Are they typically
Well,
zodiacal?
Perseus. Isn't
I don't.
No,
yeah.
no, they can be anywhere.
Perseus would not be.
Perseus, for example, is not a zodiacal constellation. If
Is it
they
close
were
to the?
originating from short period comets, they are probably going to be laid into the plane of the ecliptic,
That's
Oh,
yeah.
yeah.
right? If they're
That's
laid
what I was thinking,
into
yeah.
the plane of the ecliptic, they're going to be associated with one of the zodiacal signs like Leo. But you know, the Draconids, they're a high latitude radiant point. So there's a good example of a dramatic, which can be a dramatic and has been a dramatic meteor shower in the past.
If
And
you
there's
are
the-
looking at the sky, excuse me, Russ, the last couple of days, you're seeing a really bright Jupiter out there near the crescent moon. That's been pretty spectacular. It's been clear here in North Carolina. A lot of people pointing at the sky the few times I've seen people outside at night.
And what is it? The Halley's Comet debris is it's from Orion, right? So
Yeah,
how do you
The
say
Orionids.
Orionids? Yeah.
Yeah.
Yeah, that's true. Okay.
Yeah. So here's another perspective on the concept. Below, you know, are the chunks, the pieces, the meteorites, the meteors. They're still meteors unless they come into the Earth's orbit and land on the Earth, then they become meteorites. But so you got the meteors flying through space in parallel lines, yet from our perspective, it looks like they're shooting out from
Right, because
the
of
central
foreshortening.
point. Yeah.
Yeah. I've I love science fiction, like hard sci-fi books. I've read a lot, and Ringworld was one of my favorite series, and that gave me an exercise to visualize this kind of system, because the ring was a band that they built completely around a star. So when you're on it, you're on the inside, and what does it look like in the sky? You know, it kind of disappears to the horizon, and then it turns into this big ring arch that goes all the way over the sun. But the thing is actually a ring around the star. So that would be what these orbiting debris streams are too, big rings.
Yes,
Basically.
that's right. Big rings.
So if you're in the ring of material, it's going to be enormously wide where you are. But because space is so enormous, you can kind of look out over it, and it's very quickly gets small. So imagine you're sort of standing on the rings of Saturn. It would quickly get small and then disappear around the planet. So that's the same kind of idea, that this stuff appears to radiate from a single point because it very quickly gets tiny as it goes out into the distance of space.
Yeah. So this image up here, you know, is the constellation of Leo. The yellow lines are connecting the stars in the traditional configuration of Leo. Time lapse, but each of these meteors, if you this is an actual photograph, if you take any particular meteor and follow it back, you will see that they are emanating from a central point very close to the star Regulus. Right? Is that apparent? Can you guys see that?
Yeah, I can see it.
Yeah, it's pretty obvious. And this is interesting. That's a Leonid fireball. And it's got its own little satellite coming in with it.
Yeah, superimposed in front of Orion.
Yeah, right. Yep. So we'll stop share there. So I think everybody now has the concept of the meteor shower, how it gets its name, what the radiant is, because this is something we'll be referring to over and over again in these discussions. Especially when we start talking about the torrid meteor stream, which is going to be the one that really comes in and has a potentially very important role in discussions of the younger Dryas events. So
one of the pluses of having a backdrop there and your green screen, Randall, that comes out really good.
does it? Okay.
Give us a little tangential intro discussion there.
Mm-hmm. Yeah, actually, that's kind of why I picked it.
Yeah, that's got to be a composite too. Those all couldn't have been happening at once. So they must have been taking photographs all night and then made a composite.
Perhaps.
Of all the streaks that
Although
they got.
some of the great.
No,
You think that?
The stars in the background would be in different places.
Well, if you only did the composite of the streaks, then you could. That's. But you're right. I've been trying to imagine how this.
I'm sure.
Yeah. Been trying to imagine how this image came to be.
You could have a camera that followed just like the telescopes do.
There you go.
Follow the stars, and it would still
track this. Yeah, track that spot in the sky.
Mm-hmm.
Perhaps. Trickery.
Brad is
astronomical
skeptical.
Trickery. It's a beautiful image, regardless.
Yeah.
So since we're on the subject,
do you know what that cluster is over your shoulder?
That's Orion.
Oh, it is. Oh, it's just reversed. Oh no, it's not even. So yeah, okay, that's Betelgeuse, the big orange Betelgeuse up there. Okay, yeah, I see it now.
It's still there, people.
Has not exploded yet.
Yeah, I was just focusing on the belt and the sword there, but yeah, okay, I see it now. Sorry.
Mm-hmm. Okay, birth of a meteor stream. Let's look at this. We go bigger and here. Comet Schwassmann-Wachmann in the early stages of disintegration during the spring of 2006. And you see here it's beginning, there's a trail, which is different than the tail. The trail is the actual debris of this disintegrating comet nucleus, whereas the tail is the stream of very fine dust and gas, which is going to be affected by the very minuscule pressure of the solar wind. It's one reason why you always see the tail of the comet pointed away from the sun. If you look at a comet nucleus coming around the sun and its tail coming off, the tail is constantly pointing away from the sun. Have you noticed that? I'll bring up some slides. Maybe
you
not
expect
tonight,
it to be like, in the direction, like the opposite of the direction of its travel, but no, it's always pointing away from the sun. Yeah,
exactly.
Solar wind. Yeah,
right.
Mm-hmm. So we can see here. Here's a close up of the debris trail, and you can see there that single nucleus is fragmenting into multiple pieces. And so this is a swarm. This is a clump. Now, as this material continues to make passages in its orbit around the sun, that cluster will get spread out. And the older the stream, the more spread out and distributed along the pathway, the elliptical pathway of the material. The older it is, the more uniformly it'll be distributed. But there are clusters within that. So this, I don't know if this is going to end up making an Earth-crossing meteor stream or not. I don't think it is, but I could be corrected on that. But so yeah, here's another image taken by the Spitzer Space Telescope in early May 2006. And here you can see it's really begin to disaggregate into a whole cluster and forming the now well-known phenomena of a train, just like what we saw in the 2004 with Comet Shoemaker-Levy 9.
The string of pearls.
The string of pearls, yes. Now check this out. Here's the second generation disintegration of Comet Schwassmann-Wachmann, fragment B. So this is just, we go back, I'm not sure, let's see which one of these fragments is fragment B. But what you see here graphically depicted is this hierarchical disintegration of these cometary nuclei. So one of these fragments here, whichever one is fragment B, here is a photograph of it in the what they're calling the second generation disintegration of Comet Schwassmann-Wachmann. So Here, when you look into this cluster, there could be thousands or even hundreds of thousands of pieces in there, ranging in all different sizes, from dust size up through boulder size up to Tunguska size, which is maybe 150 feet roughly in diameter, the size of say a 10-story building, or even bigger. You might have sub-kilometer sized objects in here. Like here would be the main nucleus remnant up here. And I'm not sure of the diameter of that, but the point is, this opens the doorway to a whole nother category of phenomena that can happen. See, in these oversimplified models of impact scenarios, it's like, one rock from space hits the Earth one time and then does what it does, and then maybe not for 100,000 or 200,000 or 1,000,000 years, then it happens again, right? The scenario is getting a lot more complex than that, you see. And so a lot of the attacks on some of the impact theories are really going back to kind of some of the older models, oversimplified models of impact phenomena, which is in a way kind of a straw man. Comet linear. So here's another comet taken with taken on August 5th of 2000, and what you see here is several stages. Here's one image, and then a closer up image here, where you can, if you really look into the details of this, you see there are many, many, many fragments in there, countless fragments. So the Earth encountering something like this is going to be a completely different scenario than the Earth encountering a single, say, rock-like asteroid. Although some of these particles in here, if you will, might actually be, what we're learning about the comets is that they're really almost hybrid-like creatures. And as like we get more into the younger Dryas, we're going to see that in some respects, some of the critics referring to the impact hypothesis being a Frankenstein monster isn't really that far off the track, because what we see is a lot of different types of material that apparently were delivered to the Earth with different effects. And it also may not be as simple as one single impact, where we might be looking at several encounter type events over a period of several thousand years, and that certainly complicates the picture. So the string of pearls, let's go back to here. There is the so-called string of pearls, the Shoemaker-Levy 9 cometary debris chain. Now this started out as a single cometary nucleus, but what happened is it came too close to Jupiter. Do you understand the concept of the Roche limit, Russ? It's okay if you don't, because then they'll give me an excuse to explain it.
Sounds familiar, but I don't recall. Go ahead.
Okay, the Roche limit is simply a zone within which a cometary nucleus or any bound together object, an aggregated object, where its internal cohesion is overcome by the external gravitational field. So there's a Roche limit around Jupiter.
Like
right?
tidal forces almost on the,
where the
on
tidal
object.
forces will disaggregate that coherent object, right? Now, where exactly is the Roche limit? Well, that's going to vary depending on the nature of the object in question. If it's a lower density object that's loosely aggregated, then clearly, the Roche limit's going to be farther out for that object. If it's a tightly bound single object, like a metallic asteroid, well, then it's clearly not going to be torn apart as readily. But the idea is that if an object passes within that Roche limit, the tidal forces are going to rip it apart. And that's exactly what happened with Shoemaker-Levy 9. How many times did that nucleus make a Jovian pass? I don't know. I don't know. I haven't looked. Maybe somebody has got some estimates on it. I haven't looked into it. Probably multiple times. And as it was doing this, it probably got closer to Jupiter on each successive pass. See, this is what it was doing. It was sort of like I've said before, the ping pong ball game between the sun and between Jupiter. So on the final passage, I guess what you'd say, the penultimate passage, that object came within the Roche limit of Jupiter, and the tidal forces of Jupiter ripped it apart. And that one object evolved into 21 separate objects. And that's what you're seeing right here in this string of pearls. And here's an artist's depiction of the string of pearls approaching Jupiter. And what you saw there was in the week of July, second week in July of 2004. 1, 2, 3, 4, 5 successive 21 impacts, and they all fell into Jupiter and left these enormous plumes within the Jovian atmosphere.
Which was my background for the last episode. You had 2 or 3 of them that were visible there in the background behind me. But the previous image was probably better, but this one shows it too, just to be able to differentiate the trajectory. You know, all the objects, the bright spots are following the orbit of the object, but the solar wind is pushing the tail away from the sun. So those last 2 images you're able to see the 2 motions, or the two different angles that the thing's moving at.
Right.
I read recently as well that they're still following those plumes.
Yeah, the
From Jupiter.
Yeah,
and that was in '97, right?
To get an update.
25 years later, yeah.
If my memory is correct, wasn't there a good bit of surprise about this basically bombardment of comet fragments, that this is something that nobody really had considered before, to see evidence like this?
Yeah, pretty much.
And it was a surprise to the astronomical community, when frankly it shouldn't be.
Well, that it wouldn't be common enough that we could actually see it,
witness it,
soon after having the ability to look. It would be so uncommon that it would be, so long that we wouldn't actually see one, and then there it is.
Well, and here is an example of a catena, a crater chain, where you would have presumably the same type of a phenomena, where you have an object that's disintegrated. In this case, it looks like the cluster would be very tightly bound. In other words, the pieces are almost on top of each other when the train comes in and starts hitting one after another. Here's another example. So these things are starting to turn up, you see, that look like they're not a single impact event, but a multiple impact event, multiple impacts in one event that would probably be separated in this case by mere, seconds or minutes.
So we need to get beyond the idea of there just being one single solid object.
Yes.
These things are breaking up as they move around. They come close to objects and reach this Roche limit and get pulled apart, and then there's a debris field, and that's much more common probably, and more telling of what we may have experienced in the younger Dryas.
Yes, I think we have to look at a complex event for the younger Dryas, clearly, a more complex than the single solitary impact, which, if you read the critics, Boslow is a good example of where he basically that's the scenario he paints, is a single object with a single event. And so when we talk about the mass extinction of species, then one of the criticisms has been, well, you have to show then that the mass extinction of species all happened instantaneously, exactly when you have the deposition of impact proxies. Well, no, you don't. Because first of all, we might be talking about a more protracted event where over a period of several millennia, for example, if there is a large disintegrating comet, which is a plausible theory, and we're going to explore it in depth, particularly then when we talk about the work of Victor Klube and Bill Napier. Maybe we could even get Bill Napier on the show sometime. I think that would be really awesome. David Asher, I think his name's David Asher. He's written some great stuff about the possibility of impact episodes or impact epochs, where there is a period of time during which the Earth is going to be more vulnerable to these periodic type events, as opposed to a mere random event, you see. So I was actually showing, I had the slide up there. Let's go back to it.
And I think I mentioned this, Randall, that's where I need to go back and check for sure, but I think that's where Mark Boslow really became a prominent name, because he was involved in the tracking of the trajectory and predicting the exact time when it would hit Jupiter. And that's when he became a name that people started paying attention to astronomically as an expert to look to for these things.
Which has always struck me as odd, is why he would put himself in the forefront of trying to
very odd.
Yeah,
extremely
to
odd.
bury this idea of the younger Dryas impact. Although I have some speculation, we won't discuss that tonight. I think what would be good, though, is to actually go back into some of the responses from the Comet research team to the criticisms of Boslow. And we've gotten into that to some extent. But there's actually more really interesting back and forth between the two groups, the pro-impact group and the pros and the cons, those who are opposed to the impact. We had studies of after Comet Halley passage, I think 1986. Yeah.
86. I was a senior in high school. Yeah.
Yeah. I mean, I was out, there's a place just outside of Atlanta, which is a kind of a low profile, low relief part of the same laccolith, granitic laccolith as Stone Mountain. But back then it was kind of a very good place if you wanted to go and watch meteor showers or make any astronomical observations, because it was dark. It was on top of a dome of granite, and there were very few trees. So you got a beautiful 360-degree horizon view.
Mount Arabia, I'm trying to remember. That just popped in, and we've been out there.
Arabia Mountain, Arabia? I would be, yeah, I'm pretty sure we did go out there at one point.
But before we get off the subject of those chain impacts, I just want to say something that I've noticed, because I've spent a lot of time looking at those kinds of impact images. And this may be an artifact of the way the search works, but I tried to find evidence of those chain impacts that are old. In other words, like most of them you look at, they're on top of all the other features, right? So there will be other older impact circles, and these chains cross them, and they're on top of them. And I was trying to find out, I'm trying to look for ones where there's a chain impact and it's got an impact over top of it, a single one. And I was having trouble finding any of those. And I'm thinking, are these, does that mean that these are a recent, relatively speaking, phenomenon? And what does that mean? Yeah.
Relative dating of craters looks at superimposition. So obviously,
yes.
If you've got two craters that intersect, the one with the intact rim is going to be the younger of the two.
Right. And that's what fascinated me. I'm trying to find these chain impacts that are where they're the old ones, where there's other circles that cover over top of them. And I was having trouble finding that. So I was wondering, like, does that mean that these are more recent events? And what does that mean? Why didn't they happen a long time ago? It may just be an artifact of the way the searches worked, but I just wanted to point that out.
Well, it could be, but, I don't recall seeing any of that. But, here's part of the deal. There may be a lot more of them, but the older ones might be obscured.
Right. Yes.
So, and I've never really made a systematic search for them. I don't know if anybody has. Somebody may have.
Well, that's what I was trying to do. But
what's really cool is we've got one right across the middle of America. I think they're 200 some million years old, but right through Missouri and Kentucky, and we've been to several of them. There's a streak of 9 of them, and I can't remember if we talked about it in this podcast or on the earlier Cosmography 101 series, but yeah, we got something to look at here, right in the middle of America.
Yeah,
I don't remember that, so
we'll get to that eventually. I think,
yeah. Actually, I may have that slide right here, but this is sort of a diagrammatic representation of what they're calling a Halley type nucleus, which was post 1986. We learned a lot about comet nuclei after the studies of Halley. One of the things that emerged from this was the nature of architecture of a cometary nucleus. Very heterogeneous. A lot of water, but a lot of other stuff. Volatile gases and actually solid material on all size scales. But here's the thing. Now, this is a Halley type nucleus, and I think the Halley nucleus was at present, of course, much smaller than it would have been in epochs past. But I think it's about 10 miles in diameter, right? So if it went through this disintegration process, you can see that essentially it's almost like a multi-warhead missile in a way. It's this packaged material that begins to disaggregate, creates this clump of stuff. This stuff now is strewn about the inner solar system. And this is when the potential for Earth encounters goes up by perhaps orders of magnitude. But when you look at something like this, each one of these objects here would potentially be a large-scale Tunguska type event. Remember, if this thing is 10 miles along the long axis here, then this stuff is in the sub-kilometer range, right? Now, Tunguska is 150 feet, about 50 meters in diameter is the estimates. See, so that would be one of these like little guys, like
All
this
those
thing.
little specks, even, could
Yeah,
be
yeah,
Tunguskas,
exactly.
by the thousands.
By the thousands, maybe the tens of thousands.
I think that's really interesting that it's shaped like a seed too. You think about germinating different life, or maybe you guys got into this with Chromasinga, but just bringing new things to a planet. It's shaped like a nice seed there.
Yeah, it is, yeah.
So at some point I would love to really just delve into the whole cosmic biogenesis idea.
Yes.
Because
deeply,
for those who've read some of my stuff, you know that I'm tying some of these, which we would call a scientific concept, panspermia, which I don't know if that was Chandra's term that he originated, but I think he used it, right?
Yeah.
Right.
But that's idea is actually not, that it's actually a revived idea, that it has had various incarnations in the past. The idea that life was delivered to the terrestrial domain from space. And without getting into it tonight, but at some point we can explore that, would be like one of the repositories, I think, of those ideas is in the Grail literature for various reasons.
Yes.
Which
absolutely, we definitely need to dive into the Grail stuff for sure.
Tease
tonight.
Yeah.
Well, not tonight.
Stay tuned, folks.
But
Stay
everything
tuned.
that we are covering in these series would form the context or the background in order to see the connections, if the connections are actually there. But I would present the evidence and let the listener or the viewer make up their own minds. So, when this got proposed in 2007 by the Firestone paper, that there was perhaps an impact that was timed such that in some way it was associated with the mass extinction, the abrupt climate changes that shifted the planet from the late Pleistocene ice ages, glacial ages, into the Holocene interglacial, the melting of the ice sheets that happened inextricably fast. All of these various things that were associated with that time zone now suddenly appear to have a common factor, and that common factor is exogenic. That's the possibility that something from space acted as the trigger. Now, in response to this, there was two groups that formed. One, exploring the idea and convinced that while they didn't necessarily know precisely what happened, the evidence is definitely pointing to something cosmic, something extraterrestrial. The other group saying, no, we don't need to go there. We don't need a common explanation for these things. The explanations we have now are satisfactory. We know what caused the Younger Dryas. It was the draining of Lake Agassiz into the North Atlantic that interrupted the thermohaline circulation, the meridional overturning that we talked about last episode, and that then interrupted the delivery of heat to the North Atlantic area and the lands surrounding the North Atlantic, and that was what caused the temperature drop. That's what caused the re-expansion of the ice. But you see, something like that wouldn't necessarily be that relevant to what was happening in the Southern Hemisphere. See, so then the question became, well, is the Younger Dryas global or regional? Well, I think that's the evidence in hand now shows overwhelmingly that the signal was propagated globally. And yes, the North Atlantic seemed to manifest some of the most extreme responses to whatever was happening, but the signal was global. And we've been looking at evidence for collapse or interruption in human populations, certainly in human culture. We've seen now over North America, we've looked at some of the, I think we looked at some of the evidence for a population disruption in Northwestern Europe in the area of Belgium, didn't we? Didn't we, Belgium? And then we were looking in the Levant area, Abu Huraira, which is now in modern day Syria. We've got some more. I've actually been going back through my own archives and finding more stuff that shows that the population disruption was really widespread. But in 2009, a group of scientists led by Ted Bunch, who was one of the Comet research team, along with Whitkey West, the Kennett father-son team. I think that was the authors of it. But they published they gave a presentation at the American Geophysical Union in the fall of 2009. And their presentation was entitled A Summary of Impact Markers and Potential Impact Mechanisms for the YDB Impact Event at 12.9 Ka. Remember, BP, YDB, Younger Dryas boundary. So we'll be using that more frequently throughout here, assuming that regular listeners are going to quickly learn what we mean by that. YDB, Younger Dryas boundary, okay? 12.9 Ka, K is 1,000, A is a year, so Ka is simply a very abbreviated way of saying 1,000 years. So 12.9 Ka is 12,900 years ago. So here, this is what they said at this particular meeting. Until the announcements of a possible impact event at the beginning of the Younger Dryas, around 12.9 Ka, the Cretaceous tertiary impact layer that resulted from the Chicxulub impact at 65 million years ago was the only geological boundary known to contain coeval, meaning simultaneous, peaks in various impact markers, including diamonds. Here, we compare impact markers from the KTB, the Younger Dryas boundary layer, and the 1908 Tunguska airburst layer. Those three things. Now, interestingly, before the Younger Dryas impact hypothesis was proposed in 2007, I was very fascinated. I in fact, been obsessively fascinated with the KT boundary, which is, the famous extinction of the dinosaurs, which I've talked about. I grew up as a typical boy in the 50s and 60s, obsessed with dinosaurs and very curious as to basically what happened. That was always, every book or thing that you read about the dinosaurs always ended with the mysterious disappearance of the dinosaurs. I've described how in 1980, when the Alvarez father-son team first proposed that there was this extraterrestrial iridium layer at the KT boundary, which pointed to an extraterrestrial cause for the extinction. I was quite electrified by that idea. And I followed the arguments pro and con. I followed the controversy pretty much all through the 80s into the early 90s. One of the primary objections to the theory, the impact theory for the KT boundary, was the lack of the impact crater. Well, it's very interesting when you follow the research, and then in the early 90s, the how the impact crater is actually discovered, and really becomes sort of the smoking gun. Now, as I've followed the successive research since then, what does appear to me is that, once again, it wasn't a single solitary impact. Yeah, there was this huge impact that left the buried Chicxulub crater half into the Caribbean and half under the Yucatan Peninsula, which we want to look at because, man, there's some interesting stuff going on around there, particularly in terms of the cenote ring that was so important to the Mayan civilization that evolved on the Yucatan Peninsula. Because the whole peninsula is porous limestone, and there is no rivers flowing over ground into the North Atlantic or into the Gulf. The rivers are flowing underground through caves, through this labyrinthine network of caves and passageways and channels and so forth. The cenotes, which are definitely related to the impact itself, are the entryway into this subterranean realm of hydraulic realm where this water is moving through the fresh water. The ceremonies that the Mayans conducted with respect to the cenotes are very suggestive and very interesting. The crater itself, we'll come back to that. We'll talk about that. The point is that we've got the KT boundary, which is now, of all of the controversial impact events that have been proposed, and one of the things is that there is now tantalizing evidence for an impact event at every one of the so-called Great Five mass extinctions in Earth history, right? We've mentioned these. The earliest one, post-Cambrian explosion, is the terminal Ordovician event. That was followed by the Devonian. Then there was the Permian Triassic, the late Jurassic Triassic, and then finally the Cretaceous Tertiary. These are considered to be the Great Five. All five of them appear to have massive volcanic activity and impacts associated with them. Now, the impact event is most solidly established for the Cretaceous Tertiary boundary, right? It's not proven for any of the others, but they're finding iridium, they're finding evidence of impact proxies. We'll look at those Great Five because those Great Five are if you will, they're the framework that has essentially set life on Earth as we know it now. So, for example, the KT boundary, basically, by that catastrophe happening, it opened the door to a whole evolutionary, an exponential evolutionary expansion of new life forms, including the rise of the mammals and the appearance of hominids that presumably then led to us here tonight, having this discussion right here now in 2020, right? So now you've got that. Now that KT has provided an enormous amount of understanding and insight into the impact processes. Along with that is the discovery of several hundred other confirmed or almost confirmed impact events, right? We've got the studies showing the correlation between the rise of species and the sudden fall of species. Like I said, the Great Five all seem to have volcanism and impact. Now, what I have wondered, and this is, of course, not an original idea. I think people like Michael Rampino and Tyler Durden, what's his name? Tyler, who's written with Rampino, have suggested the possibility that large impacts, one of the consequences of large impacts may be enhanced or increased or intensified volcanism. And that sort of makes sense. I mean, think about this. If you've got an object a size of Mount Everest, 6 miles in diameter, and that sucker is moving along at 20 or 30 miles per second, and it slams into the earth, there are going to be repercussions throughout the entire lithosphere of an event like that. You know, when you think of a 6-mile object compared to the size of the earth, it doesn't seem to be necessarily that big, right? However, it's a function of its velocity. Imagine how big is a 45 caliber bullet? Pretty little, right? Right. Now, if I had the 45 caliber slug and I threw it at you, Kyle, and it hit you, it's not going to do much damage, is it? If I just threw it at you, if I chunked it at you,
If you hit me in the eye,
hit you up alongside the neck or something, you go, out, cut that out, stop that, right? But now what if I accelerated it to 2,000 feet per second, the muzzle velocity, say, of a rifle? Boom.
It would
that
bounce off
same
my
little
chest.
piece of metal is now going to be major trauma, isn't it?
Yeah.
That's how you have to think of it, right? That's like a cosmic rifle bullet that hits the earth. And what we now know is that in some cases, these cosmic traumas might be a single bullet, but at other times they might be a shotgun blast. So
It's Tyler Volk, by the way. I looked it up.
Tyler Volk. Thank you. Not
Not
Tyler
Durden.
Durden. No, not him. That's a different Tyler. He did not co-author papers with Michael Rampino, to my knowledge, anyway. Okay, so the KT boundary is one of the big, you might think of it as cosmic teaching episodes. The things that we have learned from that. In fact, without that, in the studies of that, we would probably have not really discovered the younger Dryas boundary evidence, you see. So you got that, the KT boundary, and all of the studies that have been done over that now in the last 40 years. It's been, think of that, 40 years now. Good God. Okay. The other great cosmic teaching event, which I think consider along with a handful of these things, Shoemaker-Levy 9, which we just talked about in 2004, tremendously valuable cosmic teaching event. The other one is 1908 Tunguska explosion and the ongoing studies of that event and what we've learned from that. Now, and then the other thing that has actually yielded very valuable insight into impact processes is the study of nuclear weapons detonations, both aerial bursts and underground bursts, have taught us a great deal about the sudden release of very large amounts of energy in one concentrated place. So we will look at all of those things because one of our goals here is to try to really come to a comprehensive understanding of this interaction between Earth and cosmos, which I'm hypothesizing is fundamental to pretty much everything. It's fundamental to the rise and fall of species, the evolution of species. It's fundamental to the rise and fall of civilizations. It's fundamental to the understanding of the global geology, the lithology, the way water moves through the crust, volcanism, geomagnetism. The list goes on, right? This is why I think it's so damn important that we really have to begin looking at the big picture and realizing that Earth is part of a cosmic ecosystem. And that if we want to talk about sustainability in the long term, we have to look at it in that context. We have to look at it in terms of Earth as a member of an extraterrestrial environment, an extraterrestrial ecosystem, if you will. So
maybe
go ahead.
It may be fundamental to life on Earth as well, which is
in terms of what you guys just interviewed Chandra Wickramasinghe, right?
That's right.
And that we have a cosmic biome. That is a fascinating concept right there.
Yeah, and see, this is when I'm regurgitating these ideas, I'm going back, like we were talking about before the show. They're Chandra's co-authored book with the late Fred Hoyle, Diseases from Space, was one of the ones, I think it was 78 maybe, that it was first
Somewhere around
published.
Something
yeah.
like that.
Somewhere around there, yeah. I mean, I don't think I got it the year it was published. I think I picked it up 2 or 3 years after, maybe in the early 80s, when I really, because it was post 1980 that I really came full circle back around and got just super fascinated by all of this kind of stuff, comets and asteroids and impacts and cratering and the planetary environment, and so planetary geology and so on. So I think it was maybe about 1981, 1982, right in there, when I encountered diseases from space. And subsequent to that, I've read, probably 4 or 5 other books, either co-authored by Hoyle and Wikramasinghe or individually by them. Fred Hoyle's book on the start and cessation of ice ages, I think, is perhaps very much on track, particularly when he's talking about what could actually trigger the onset of a full glacial age. So we're bringing all of these things together to try to get this coherent picture. Okay, so in this article, 2009 article, Bunch, Schultz, Whitkey, West, the Kennets are talking about the prior to the discovery of the nanodiamond layer at the Younger Dryas, the YDB, the other area, the other layer where it was known was the KTB, Cretaceous Tertiary boundary. So here we compare impact markers from the KTB, the Younger Dryas boundary layer, and the 1908 Tunguska airburst layer. First order markers related to impact and biomass burning include, and here's the list of some of the things: magnetic spherules, carbon spherules, nanodiamonds, both cubic and lonsdaleite. Lonsdaleite, if you will remember, is the hexagonal form of nanodiamonds, iridium anomalies, charcoal, fullerenes, right, with a high 3 helium to 4 helium ratio, grape-like soot, which is also called aciniform soot, and this is where you have soot, clusters of soot that are basically welded together and look like clumps of grapes under the microscope, and widespread extinctions. Observations and analytical data for the YDB are consistent with all of the KTB markers. While the last 3 markers, which would be the extinctions, the fullerenes, and probably lonsdaleite.
Grape-like soot.
Pardon me?
I thought it was the grape-like soot.
Well, I think there was grape-like. Maybe it was grape-like soot. Okay. Observations and analytical data for the YDB are consistent with all of the KTB markers, while the last 3 markers are unknown and inconclusive for the Tunguska layer. Selected markers for cratering events, such as Chicxulub, are a visible crater, shocked minerals, impact breccia, and microtectites. None of these are yet known for the YD event or Tunguska. So in other words, when they're writing in 2009, there's no crater known either for Tunguska or the Younger Dryas boundary. Okay. Now this is, of course, was 11 years ago. Things have changed somewhat then. Now, shocked minerals, that's referring to silicate-based minerals such as quartz, which under impact, the shock waves, we talked about this, passing through the minerals cause these very fine fracture lines to occur and form these patterns called PDFs for parallel deformation features, because these little fracture lines tend to be parallel. Microtectites. Now, microtectites is when you have an impact and you have the vapor or the molten material ejected into the atmosphere, and as it falls back, it assumes these aerodynamic shapes. And of course, microtectites means that it's small, so it's probably directly a consequence of vapor deposition. So it's very small when it falls back to Earth. Macrotectites, you can actually pick them up and hold them in your hand. They might be 2 or 3 inches in diameter, right? Now, this is molten material falling back to Earth. And that molten material is going to consist of both the terrestrial target material and the material composing the impactor itself. And finally, impact breccia, which is simply just the broken rock and debris material from the force of the impact that has been thrown up and falls back to Earth. Typically will form a layer, like in a crater, the impact breccia. What'll happen is it'll form a layer of this broken rock, usually that gets filled in by by fluids flowing in the apertures and filling in and mineralizing. But below that, oftentimes there will be a melt layer, a melt rock layer from the heat of the impact, which could be 10,000 degrees centigrade. From the heat of the impact, it's going to melt everything. And so it's going to leave this vitreous layer. And then the impact breccia comes back down and falls upon the top of that vitrified layer. So if you dig down through, if you take a core sample, you come up and here's a bunch of shattered and broken rock of all different sizes. And then you get through and there's glassy like stuff. Pretty good indication. And guess what? That's kind of what the scenario was at the case with the discovery of the Chicxulub crater, was that there was this vitrified layer and there was breccia, both impact breccia.
Randall, let me jump back just for a second there to make sure we get something right. Testing my memory here, because it was a couple of episodes ago we did touch on this. The PDFs. I think you had said planar deformation features.
Yeah, planar.
Okay.
In plane, yeah. I think I just said parallel because
you said parallel. So okay, I want to just make sure we had
which
that right.
which the fracture lines do tend to be parallel, and they make this a pattern called a Widman-Staton. I think it's called pattern. But yeah, planar deformation features is the more accurate term.
Okay, good.
Absolutely. It's kind of like, when you see CAL, YR, BP, right? What that means is calibrated years before present.
Before present, yeah.
Right? However, oftentimes it gets interpreted and accurately.
Calendar.
I mean, because then the meaning
calendar.
is, yes, calendar, exactly.
Yeah.
Exactly.
So
planar parallel. Gotcha.
Yeah.
Excuse
does
me,
the Barringer crater have that? Do you know if they found that vitrified layer down there? I know they've dug into the center of Meteor crater.
Do you remember, Brad? I don't recall anything specific about.
I don't remember that either. I don't think so.
Yeah, I probably could look it up, but I just was wondering, like, man, I wonder if they found a bowl of molten, of glassified material down there underneath that thing.
Mm-hmm.
I'd be interested to look up.
So then,
it wasn't for lack of searching, because they definitely dug a lot under there.
They excavated the impactor.
So they go on to say that the discussion here is limited to possible origins of the impact markers and not with impact consequences such as climate change or extinctions, etc. Okay, that's fine, right? Several origins may account for impact materials in the YDB. One, an extraordinary accretion of micrometeorites, which was kind of the idea of some of the critics, particular Pintar and Ishman was, I don't remember his first name, but they were in the forefront along with Boslow and several others of being the critics. And they said, no. This is just the steady rain of micrometeorites that's happening all the time. No catastrophe involved. However, this, as this team, the Bunch, Schultz, Whitkey, West, and Kennett team says, this, however, is inconsistent with the YDB carbon spheral compositions, including the large concentrations of nanodiamonds found embedded inside those carbon spherules. Two, as a possible origin for the impact material, oblique now this is where, to me, we're getting right on the scenario where Brad and I have been exploring this idea since the late 90s. We made our first trip to British Columbia in 1999 looking for evidence of an impact into the Cordilleran ice sheet. And we've made multiple subsequent trips into that area since then, looking for evidence that there could have been an impact into the Cordilleran ice sheet that led to catastrophic melting, and then may be related to the so-called Missoula floods that occurred, which, you know, is another thing we're going to be getting into in depth very soon, particularly because we're planning this week in the Channel Scablands next September. Which,
So
go ahead. Yeah.
I have a question about that.
Yeah.
Is it, I mean, the critics are all saying, where's the crater?
Where's the crater? That's one of the big stumbling blocks right there.
Montrose.
Where's your crater?
The proponents are suggesting it was a bombardment that perhaps, you know, hit the entire hemisphere. If they were a bunch of smaller Tunguska-like objects that exploded in the atmosphere and didn't make a crater, but all that heat and the shockwave force is knocking over trees, melting stuff, burning everything.
Mm-hmm.
What I don't understand why there has to be a crater in order for the critics to.
Well, I think that's precisely the point. There doesn't have to be. And well, so listen to this. Let me go on to option 2 here.
That was sorry. That was just going to say that was the precedent that was set with the KT. You know, they wouldn't accept that until they found the crater. So that's
right.
That's the pattern that they know to go by. Well, okay, we're going to resist until you find your crater.
Exactly.
Okay.
Yeah, sorry.
So here's option 2 as far as the origin for the impact materials. Oblique impacts, meaning coming in at an angle, a relatively shallow angle rather than this, right? Oblique impacts into the Laurentide ice sheet. This model is consistent with the lack of a visible crater and apparent lack of cratering markers above, and yet also provides for shock production of the many cubic nanodiamonds and lonsdaleite found in the YDB. And then the third option is impact-induced aerial burst. Now, I would look at options 2 and 3, right? The lack of an impact crater being the direct result of what would happen if, let's say, an object, you know, let's say, 500 meters in diameter, 1,500 feet, right? Or up to, let's say, even up to a kilometer, sub-kilometer up to kilometer size, crashing into an ice sheet that might be a mile thick, right? That is not going to create a classical crater that you would look, for example, Meteor crater in Arizona. It's going to create something really very different. And what we have to do, and the problem is that there hasn't been a huge amount of modeling to understand what happens. There's been some, and I'm pulling some of that together. But the idea is that if you have an impact into an ice sheet, you're going to have this whole array of secondary consequences. One, you're going to have extreme melting right at the epicenter, right? You're going to have the injection of material into the atmosphere that is going to be both from the ice sheet itself and the impactor.
Yeah.
You're going to have fracturing, extensive fracturing in the ice mass as well. You're going to have a huge amount of meltwater that's generated. And somebody posted a comment in one of our earlier episodes saying, well, there wouldn't be enough heat. No, that's completely wrong. There could easily be enough heat to melt a very large amount of meltwater, again, depending on how much energy is released. And that's going to be due to the mass of the object and its velocity at point of impact.
And the fracturing would give it give that meltwater and the pressure from that meltwater all these channels to go and begin eroding.
Exactly. Now, what that does is facilitates the access of the meltwater to the base of the ice sheet. Now, when
be clear
we look,
that it's not melting 100% of the ice sheet. You know, there's plenty of dead ice that remained afterwards, but I think people want to think that you're saying absolutely every little bit of ice melted, and that's not
I'm
what you're saying
absolutely
at all.
not saying that.
Right.
And yes, the evidence shows that there were huge masses of stagnant dead ice in the aftermath of whatever happened during this younger Dryas stuff. In fact, a lot of the, you know, we did get into some of the energy requirements for let's say a uniform recession of the ice masses until it was virtually gone, like today, and discovered that the totality of the energy requirements is truly off the charts extraordinary, right? However, when we look at the landforms in the aftermath, and we will do this, I'm going to fully educate as much as I can the geomorphology of the deglaciation process. What you're going to see is that there's evidence for large amounts of dead ice just strewn over the landscape, which again is exactly what you would expect to find. Now, in one of the analogs that we can use in trying to understand what an impact into an ice sheet would be is by looking at the studies of oceanic impacts, which again is a very limited range compared to impacts on land. Yeah, studies of oceanic impacts are quite scant. There's not a lot of them, but what we do know is this: that there's an impact in the form of a transient crater. The water will rush out, but then what happens? It rushes back in. And this is called, actually given a name, it's called the resurge wave. That resurge wave that comes in is loaded with sediment and material, right? Now that's all rushing back into the point of impact. Boom. If there is a crater that has actually been excavated below the ice, you got a picture that this water is rushing back in and it's filling that crater with sediment. And so what it's going to do is it's going to, and it's also obscuring any rim that forms around the crater as well. So, you know, you got to look for something completely different. And we will get into that for sure. In fact, at that point,
we're creating lots of drumlins too.
Exactly. Now we will, when we get back in, we're going to get Jerome Lessman on the show. And we'll be talking about drumlins and the work of John Shaw, which I think dovetails right in with this. Now, of course, when you look at the late John Shaw, I think we talked about him with the episode with George Howard on here. You know, the critics attacked his idea of gigantic subglacial floods. And he came to this idea because he was studying the vast, very extensive drumlin swarms that occur in the glaciated areas. Well, geologists have been arguing for 150 years what's the origin of these drumlins without ever coming to any kind of a consensus at all. Now here comes John Shaw saying, well, everybody is looking at trying to imagine various ways that the glaciers themselves, by plowing over the thick layers of glacial till, are somehow shaping them into these aerodynamic forms. Now, John Shaw comes along and says, well, no, it's not the glaciers directly, it's water. Huge amounts of water, which is implicit in the vast, extensive geographical distribution of the drumlin swarms. He says, look, we can explain this, but we can even show. We can show in the laboratory. We can show in hydraulic modeling. We can show examples on microscale. Exactly the type of feature you see in a drumlin. And these are formed by flowing water, especially if the water has no free surface, it's under pressure. All the critics came back and said, in echoing the critics of J. Harlan Brett's, decades and decades earlier, that you cannot provide a source for that much water because the drumlin fields are so huge that the amount of water required would be phenomenal. you have no source for such water. So they looked at possibilities. Could there have been a big subglacial lake that formed? Well, yes, but, and then they cited examples. Well, there are huge subglacial lakes in Antarctica that we now know about. Problem there, though, is those lakes in Antarctica are actually in bedrock basins. So if you were to remove the lid of ice, you would have a lake held in a basin. It's not held in by the ice, you understand? So whereas Shaw's ideas would have required huge reservoirs of water under the ice that is somehow held in by the ice itself. Then they said, well, what about if the ice, if the water formed on top of the glacier, supraglacially, rather than subglacially or n-glacially, which is within the mass of the glacier itself? Well, they said, well, no, because we know from the studies of modern glaciers that, yeah, in the spring, water, in summer, water will certainly pool up on the surface of a glacier, but it doesn't reach anywhere near the scale and extent that would be required for the formation of a drumlin field. And it will quickly find ways to percolate through the ice, either through moulins or, interstitial cavity or whatever, to get to the base of the ice sheet before it really could ever even get close to something required to produce a drumlin field. So basically, the critics dismissed the work of John Shaw by saying you cannot provide a source for that much meltwater. But perhaps we do have a way to provide the source for that much meltwater. And now enter the Younger Dryas boundary impact hypothesis. Now, Shaw's ideas on drumlin formation go back to the 1980s. So, I mean, he's writing papers with all of his colleagues and things, from the late 80s through the 90s into the 2000s. So, and it's just, I'm saddened that I didn't get to meet the gentleman. I think we talked about that. He was very excited about joining us up at potentially at Lake Nipigon, and then regrettably passed away. So, but he left us a group of successors. And Brad and I were privileged a few years ago to spend about 4 days up in the drumlin fields of the Chaco and Fraser Plateaus up in British Columbia with one of the leading students of Shaw, and one who I would consider to be probably one of the foremost authorities on drumlin formation on the planet today. So we will be coming back to that. So stay tuned for that.
Thompson Plateau also, I think.
Yeah, I
think Thompson and Fraser. I'm thinking Chaco was a little bit north, but yeah.
Yeah, maybe we did. You and I got there on a previous trip, but we didn't get up there with Jerome, did we?
Right. Yeah. Well, I think the chasm that we just branched up into is coming off of the Chaco down into. I
think you're
Thompson.
Right. Yep. I think, is it chasm or chasm?
It's one of those. Yeah.
One of those.
Chasm.
Crevasse.
Chasm.
Crevasse.
I'll just say
crevasse. That's
crevasse.
Like. Yeah.
It's not crevasse. No? Okay.
So just, well, I think that's it. Yeah, go ahead.
I was just going to say one other thing I would be interested to learn about would be the effect of the shock wave on the ice. Right? Because it's so brittle compared to, crustal materials especially if you imagine the impactor could go deep into that ice, deeper than it would if it hit the crust. The shock wave from that just moving through the ice sheet.
Oh yeah. I mean, the Tunguska event had a shock wave that actually registered seismically, I think, as like a 5.5 earthquake. So yeah.
Yeah.
Now imagine you got something doesn't even strike the ice sheet, but maybe is 3 or 4 to 10 times the mass of the Tunguska object. Yeah. Imagine that you're propagating a seismic shock wave through the ice itself. Yeah.
Yeah.
Decoupling it from the land surface too.
Mm-hmm.
Yeah. I mean, I don't know if you've seen the videos. I think they're NASA videos. They show, they've got this machine for shooting BBs basically at
sure.
surface materials.
Yeah.
And they
Rampino's work.
they shoot a BB at an ice layer over soil, and the ice layer simply fragments, and there's no impact crater in the soil.
Right.
Wow.
Now, the thing is, if you have a big enough impactor, then of course, it will make
Yeah.
a crater underneath.
Yeah.
But even there, you've still got to look for a whole different set of morphological characteristics because of the fact of the resurge wave and so on. The fact that you're also that breccia that falls back into the crater is also going to include a lot of ice.
Right. And then once it melts,
there's a huge erosive factor. Yeah.
Exactly.
Yeah.
And, Tony Zamora's idea is interesting. Obviously ignited a lot of controversy. And it would be fun to get Tony on here. And I think he would be willing to get on here and talk about his ice boulder hypothesis. I think it's worth considering. I'm not convinced. I kind of still am sticking to my older ideas of Tunguska, which we will be talking about further, because obviously one of the reasons I'm getting into Bunchwood's work here is because he does reference Tunguska, and it'll be a good lead in to doing a couple of episodes about Tunguska and some of the cosmic lessons we've gleaned from the study of that event. Anyways, so they go on to say the lack of high shock pressures in an aerial detonation does not necessarily preclude the formation of cubic and hexagonal diamonds. And he shows, as shown by Maruyama and others in 1993, who made hexagonal and cubic diamonds by a carbon vapor deposition process from a high temperature plasma atmosphere of at least 13,000 degrees centigrade under pressure conditions similar to those in an aerial burst. We can get back into what we don't have time to talk about at night, but a CVD, which is the carbon vapor deposition process. Potentially very interesting as to what's going in the alchemy that's going on in the atmosphere during one of these events. The Tunguska event is commonly accepted as the result of a near-surface aerial burst and has many similarities to the YD event, which of course is useful because we can extrapolate in the lessons we learned from the KT boundary, from the Tunguska event, from nuclear detonations. All of this can give us the perspective we need to really get down and try to understand what happened at the YDB. Now, and we're still going on here as to possible origins. So another one is comet grazing in the atmosphere, involving nearly tangential entry of a comet into the Earth's atmosphere with partial detonation and melting, followed by the escape of the unexploded nucleus into space. Now, I'm reiterating what we talked about, I think, last episode, and Brad had the graphic of exactly what this scenario is describing. If the tangential, here's the Earth, tangential, right?
Yep, that was 2 episodes ago, actually.
2 episodes ago, yeah. So go back, if you will, and review that.
End of 23, we're doing 25 now.
Yeah. So involving nearly tangential entry of a comet into the Earth's atmosphere with partial detonation and melting, followed by escape of the unexploded nucleus into space. This would be the scenario I would be leaning towards. And that's why I did that graphic probably 20 years ago.
There it is.
There it is right there.
Love it.
Yeah. I mean, at what point, I was trying to remember when I did this. I mean, had to have been 15, 20 years ago. I mean, you recalled seeing it a long time ago, right, Brad?
Yeah, at least 15 years ago.
At least 15.
I think that's probably a derivation of Hale-Bopp because it had that obvious second blue gaseous tail on it. It was probably, some derivation you modified there.
Yeah,
Hale-Bopp.
And
it's
that
extraordinary. That really gives you the vision.
Well, so that was 1997.
Right.
So we're looking at, 23 years ago? But this would have been
came through, but
right. This would have been subsequent to that.
Yeah. Correct.
Right. So we know less than 23 years ago. Okay. Maybe actually I find the original graphic may be dated. He says that 3 of these 4 scenarios are plausible. The fourth that he doesn't think that this team doesn't think plausible is the Pintar-Ishman scenario of a slow, steady accretion of micrometeoritic dust. Okay. So, Tunguska, very a valuable lesson that we've got. And so that's why I would like to get into that and see what we can learn from it. How's our timing?
Oh yeah, we about time to wrap up.
Pretty close, yeah.
Yeah. You think we'd be doing Tunguska soon?
Close.
Maybe next week or
yes,
or a little later. Okay.
Yeah. In fact, what I plan to do is to begin introducing Tunguska material with the YDB material as it's germane,
pertinent. Awesome.
But then we'll probably devote like a whole episode or two just exclusively to that, because I'd like to delve into some of the eyewitness accounts because they're pretty extraordinary.
Yeah, and look at some of the graphics and the pictures and the overheads and
absolutely. Yeah, so that's my plan, and I'm sticking to it. I don't care what you guys say.
We'll be back. All right. Well, we got 5 minutes to wrap it up, and we'll be right at it. Can you stop there?
I could stop there. Or I could go on and on and on.
We know
and
that.
On and on.
Well, just to kind of wrap it around a little bit, what was the term that you used for the water rushing back into the?
A resurge wave.
Resurge. Yeah. Okay. Yeah, I hadn't remembered that term. Resurge wave. Okay.
Mm-hmm. Yeah, that's what that was. So.
And just to get an image for people as we move forward, we'll get back to this, but if you have an impact and the water's rushing, instantaneous melt water's rushing super glacially, right? And then through these cracks and different cavities you're talking about, gets back into the base of the ice because, as I said, it's been decoupled from the ground. It's rushing back toward that resurge wave is over the top, super glacial, but also subglacial. And that's when you're going to get some of those drumlins that seemingly may be pointed the wrong direction for you, where you would think the water flow would be.
Exactly.
That's coming back in from the bottom also.
Yes.
So just to start to get that vision, and we're going to get details into later.
Yeah. So the original rush outward could possibly have shaped the subglacial till into the aerodynamic drumlin-like forms. Then the rush back in, though, would then modify those, right? So, yeah, that's exactly right.
Yeah, and then after it rushes back in, it begins to flow in whatever direction all of it wants to go, and then it modifies it again, possibly.
Yeah.
Right, because there's going to be a third direction of flow, which is going to be the downhill slope, I guess. Mm-hmm.
All kind of complexity that practically no studies have been done on, I don't believe.
Wow.
Well, we'll see that because, we'll be tying in, because Brad and I have spent so many hours and hours and days and weeks up in the various floodlands, not only of the Cordilleran ice sheet, but the Laurentide ice sheet. And of course, there's a lot more. I mean, in spite of the fact that we've logged up, 100,000 miles, we figured roughly.
Oh, yeah, we're on the plus side of 6 digits now for sure.
Yeah. Boy, I mean, we're only scratching the surface of this stuff.
Barely.
So you guys have gone like halfway to the moon, roughly.
Well, yeah. I guess if you want to look at it that way, yeah.
4 circumnavigations of the Earth. Yeah, either way. We've been out there on the road, no doubt.
Oh, God, yes. Yeah. And Brad has been driving every inch of it.
Right.
That's all right.
Listening to 9 Inch Nails.
I'm ready to go again tomorrow, man.
Yeah. Let's go. 9 Inch Nails. Well, we have one coming up this September, so that one's going to be a blast. People can join us for that.
Well, yeah, so we're set up for the first week. We've got a resort, which is a cluster of cabins. How many cabins, Brad? 6, 5?
I think I was going to say 8, but yeah, 6 to 8.
6 to 8.
6 to
Okay.
8.
Then there's a building which is a good, almost like a conference style building where we're going to have, briefings and meetings and so forth. We'll spend a week out there exploring the Channel Scablands, using this as the base. It's at the southern end of Soap Lake, which is at the southern end of Grand Coulee. So we're right in the middle of this extraordinary Channel Scabland complex. So we're going to spend a week, and the people there at the resort, they own a restaurant, so they're going to be doing all the catering. We'll have a couple of tour vans we'll be leasing for the week to get out and explore. First week is full. So I guess we're considering a second follow-up week. And I have not made a decision yet. But we'll see. I mean, if there's enough interest. So each tour group is limited to 25 people. Because we want to keep it, we want to keep it constrained
Manageable,
enough
yeah.
that and then as part of it too, we would have a series of briefing meetings like we did with the contact at the cabin in southern Colorado, so that people can get up to speed on the geography and the geology, and this is what we're doing, this is where we're going to go, this is what we're going to look at, and this is how it all fits together. These are the terms we're going to be using. So now you've got this basic understanding before we even step foot out into the floodlands.
Right. And those meetings will be just like this.
Just like this.
Just
Zoom,
like this, yes.
but with like 25 people. It's a lot of fun.
A lot of fun. Yeah. The meetings we had prior to the
You can't
Colorado
point,
trip
Brad.
were a lot of fun. And looking up here, look at Brad up here. This is Grand Coulee up here behind him. Right there with his hand that's Soap Lake.
It's Soap Lake, but my finger's not there. But yeah, imagine an extended index finger there.
I'm trying to scroll over it with my
You're-
mouse. You can see. So we've got the Telford Scabland tract here. Looks like it's coming right out of Brad's
We can't
skull.
see your mouse.
You see this?
We can't see your mouse either. Yeah.
Oh,
Brad
you
has
can't
to
see
point.
my mouse?
No.
Oh,
Share
Well-
your screen.
But
Share
you
your
can
screen
see
and then point at Brad's picture.
okay.
you can't
Share
do that.
screen.
You can't share
Well,
Zoom.
yeah, there you go. Will
You
it
can't
be
share
in
Zoom.
motion? Will it be in motion? That'd be cool.
Let's
No,
see.
yeah.
I don't think
I
we
don't
tried
think
that.
You can't.
Can I?
No, you
Let's
can't
see.
share your Zoom screen.
It won't let you share itself.
Oh, it won't. No.
Yeah.
Okay. So forget it then.
It would set up
right.
some multidimensional.
I know we would
feedback.
probably all disappear into a wormhole if you did that. It
We'll
would-
spend we'll spend quite a few episodes leading up to that, though, going all over this map.
Oh,
Yeah.
hell yeah. Hell yeah. So yeah, this whole thing
satellite
here
image.
is the Columbia Basalt Plateau, which actually has a very interesting potential genesis story behind it, which we'll get into, obviously. But it might actually be related to the Yellowstone magmatic plume that some people are worried about.
Caldera there, yeah.
Yeah. 17 million years ago.
What magnetic plume?
Magmatic.
Oh, magmatic plume.
Magma.
Yeah.
Right. Magma. Yeah. So-
Are you going Electric Universe on us now?
I was thinking, is this another Electric Universe thing?
Not intentionally.
Trying to please all crowds here. All right,
Yeah,
so-
you know what I've quickly learned by doing this is you can't please everybody. And then if you
No
shift
doubt.
over to please somebody who's not happy about something, then somebody
Everybody else gets mad. Yeah.
somebody else gets mad. So
Because they
We're
were
trying to-
wrong.
please the greatest number of people possible, but hey,
Yeah.
some of you guys might fall through the cracks and we apologize.
Sorry about that. You mad, bro?
To quote Gray Slick, feed your head.
If you're gonna get mad, just get mad at me.
Yeah, that's why we
Right.
keep Kyle around.
That's why I'm here.
Yeah. That is our job, sort of,
Yeah.
to absorb
Kyle-
the anger.
Deflect.
Kyle is the officially designated scapegoat.
That's right.
So if anybody has an issue with anything, if I misspeak on something, then
Yeah. Take it up with Kyle.
Take it up. Yell at Kyle.
Well, let me say something quick here as we're wrapping it up here, because we've moved the podcast to the Randall Carlson channel on YouTube, and the episodes there had only gone up to 10. So we've started republishing them there exclusively with 2022. Okay, so 10 to 11 to 20 were missing. So I'm starting to plug those back in. So the whole run is on the Randall Carlson channel. So the episode number is in the title, it's in the description, it's on the thumbnail. So yes, if we went from 25 to 11, yes, this is a rerun from GeoCosmic-Rex channel. We're putting them all in sequence on the new channel. So yes, those will be coming out fast and furious, as fast as I can do them here over the next 2 weeks to get this caught up. So they're all on the Randall Carlson channel. So yeah, the two that came out earlier today, we're recording on Monday, the 30th. Yeah, those are reruns, but they're going to make the full gamut available on the Randall Carlson channel.
Yeah, and that's also a lot of work. So thank you very much, Brad, for doing all that work.
Yeah.
Also, we apologize for those of you who are listening to the last show that it came out mono for so long. We thought we had replaced it with a stereo version. It was a mistake. We didn't replace it. We just replaced it.
Yeah.
You've probably known that by now. But if you want to go back and listen, it's in stereo
version. Yeah.
My fault.
So, yeah, there's a lot of changes.
I'm getting better.
It was my fault. There was
Blame Kyle.
There's a lot of changes going on, and we're trying to streamline things. So, bear with us, and thank you to everybody who has.
Yeah,
really
more great
appreciate
stuff.
you guys.
More great stuff coming soon, and Patreon still building, and we are so appreciative of all those people that really support this work and believe it's worth putting some bucks into. And we're going to continue to get better at this, and we really thank you.
Oh, I want to second that, and yeah, that is really beginning to help, and I can see that this is going to be an exciting thing, and we're going to get through this extraordinary stuff that we're in the middle of now. And when we do, it's going to be all speed ahead.
That's right.
Full speed ahead.
Full speed ahead. Yeah.
Full speed.
And it is great to see
that
those Patreon support coming in almost every day. There's new ones, so we thank you guys so much for that. Really
outstanding.
And
yeah.
For the website, for emailing us, for the Patreon support, for the PayPal, everything, all the links are down in the show notes. Links are also in the show notes for what else, Brad? The video channels, playlists.
Contact at the cabin, the trip
right.
in late September.
Scablands.
Second one would be early October if enough people want to jump in, and the world's back to semi-normalcy that we can travel cross country and explore those Scablands, man. Incredible landscape.
Yeah, make sure to check the show notes. If you're wondering about details, show notes.
Show notes. Brad does enormously extensive, very awesome show notes. So they're always
trying to
there.
cover it all. If I miss something, let me know, and I'll throw it in there too.
I'm going to say this about the Scablands. My first experience with the Scablands was with Brad on a trip out there in 2014, and it is overwhelming. I mean, it's one thing to talk about it, to look at the maps, look at the Google image and all stuff, but to actually see those ripples, to get up on a ridge and see those massive ripples and look at a car down there driving through and realize those ripples are, 50 feet, 100 feet high, and just, it's amazing. It is completely overwhelming.
Now, which ripples
that's in Montana. Mike went through us with Camus Prairie too, but there's some in West Bar.
See,
there.
It was
not
so
cars, but there's a boat. So
it was so overwhelming. I get the geography mixed up.
Yeah, it's all right.
Well, you
It's
realize
okay,
how huge the event had to be to cover that much territory. Once you drive across it for days, and you're still going through the flood-ravaged territory, it's like,
exactly.
Yeah,
starts
it.
to penetrate your brain. It takes some time though.
Yeah.
To grasp.
And there at Soap Lake, you're staring up the lake and up the channel at and looking up the escarpment on the left side, and it's
the
just
west side. Yeah.
It is.
Gullet.
Yeah, just amazing. Absolutely amazing.
All right.
Yeah, I can't wait. I'm getting excited now. I'm not, but we're gonna have to wait till hopefully by September. All of this is behind us.
Right.
Hopefully in 30 days, it's all behind. If they get those testing kits out there, and I'll say one thing, what they need to be doing, and of course, I think this is going to happen, they need to be testing for antibodies.
Yeah.
Because that'll tell us who's had it. And once you've had it, hey, you're in the clear, man. And there was those few weeks, I guess, was it early February, late January, where I was.
You and me both. Me in December,
January.
and you in January.
Yeah.
I'd like to see the antibody test. I think I might pass.
Yeah, because who knows, Mike? You and me might have had it.
Yeah.
And what you guys were saying last week, because I hadn't even thought of that. Atlanta International Hub, planes coming in and out, coming from China.
Yeah,
totally.
For several months before this thing even came on the radar screen. Yeah, right. I mean,
or if you believe Wick promising, it's just falling down on us. So
yeah, it's coming from space.
Well, yeah. Although in his scenario, there will be pockets where.
That's right.
Yeah.
Yes.
Yeah.
Yep.
Listen to Brothers of the Serpent, episode
141.
All right.
Wow.
I'm going there tomorrow.
All right. Thanks guys.
Buddy.
Yeah.
Well, yeah, I might.
Well, this was a great show, guys. Looking forward to next week.
Me too.
Yeah.
All
awesome,
right,
guys.
Gentlemen,
thanks a lot.
Good night.
Good night.
Good night, Snake Brothers. Good night, Brad. Good night, normal guy.
Handler.
Who's not quite as normal as he was when we started this series.
Nice shirt, normal guy. Aloha.
Aloha. Mahalo.